In order to factor, you will have to know how to divide. So that is going to be your background necessary for this video. To factor basically means to break down a number into smaller numbers or expressions into smaller numbers and expressions so that when you multiply, you get what you started with. So, for example, if I take the number 6, if I wanted to factor that, I can write it as 2 times 3 because I'm writing it in such a way that I can see the breakdown of the number. 6 is 2 times 3. Now when you break it down so that these numbers cannot be broken down anymore, this is called your prime factorization. For example, you have 12, which can be represented as 4 times 3. However, 4 can be broken down as 2 times 2, and of course that times 3 would give us 12. So while this is considered factoring, this is the prime factorization, since the number is broken down into products of prime numbers. And this is what we're going to need to know how to do if we're going to factor the GCF.
Hey, if you haven't liked, shared, or subscribed yet, go do that now. Okay, bye.
We'll start out with the example 8 plus 6x to the 4th. We want to break down 8 first. That would be, and we can do that aside, 8 can be broken down as 2 times 4. 4 can be broken down as 2 times 2. So the numbers on the ends of the stems, 2 times 2 times 2 is 8. So we'll write that here as 2 times 2 times 2. But we want to also break down 6x to the 4th. 6, as we've seen before, is just 2 times 3, and that is the prime factorization. Then x times itself 4 times. Now we will see what they have in common, and they have a set of 2 in common. So when we're factoring, we're going to take the 2 out, because that's what they have in common. And what's left in 8 is 2 times 2, which is 4, plus what's left of 6x to the 4th is 3x to the 4th. And this is how we would factor out the GCF. Keep in mind that the GCF is the greatest common factor. So in some cases you may have taken out a common factor, but if you're factoring out the GCF, you're looking for the greatest thing or the greatest number or expression you can take out from an example, like this. So let's do a second example. 4n to the 9th plus 12n. Now here, it's obvious that these two are divisible by 2. But is 2 the GCF? Probably not. Let's check. So for 4, we know that can be broken down as 2 times 2. And then n to the 9th is just n times itself 9 times. So 4n to the 9th is 2 times 2, and n 9 times. Then for 12n, we want to break down 12. So 12 is 2 times 6. 6, though, can be broken down as 2 times 3. So 12 is 2 times 2 times 3, as we saw here. So 12n would be 2 times 2 times 3 times n. Now we notice they have a set of 2 in common. they have another set of 2 in common, and then they have a set of n's in common. So the GCF is 2 times 2 times n, which is 4n. So we'll write 4n outside the parentheses, multiplied by what's left. So we've taken out 2 times 2 times n, which is 4n, and what we're left with is 8n's. So n to the power of 8. The sign is positive, so we keep the plus here. And then once we take out 2 times 2 times n here, which is 4n, we're only left with 3. So then this is 4n times n to the 8th plus 3. And that is how you factor the GCF. Now keep in mind that once you're done factoring, you should be able to multiply this expression to get what you started with. So 4n times n to the 8th is 4n to the 9th, and 4n times 3 is 12n, which is what we started with. So you can always check your work that way to make sure that you have factored properly.